Imagine for a moment looking up at the night sky, the stars, distant and mysterious, scattered across an endless expanse of darkness. We've always gazed up there, wondering, what if? What if there's more out there? What if there's another world, just beyond our reach, waiting for us? And just maybe, what if one day, humanity could take its first steps on another planet, one that isn't even part of our solar system? Well, that what if is becoming less of a question and more of a reality. This isn't just science fiction anymore, it's science fact. It's happening. The dream of reaching another star, of stepping foot on an exoplanet, is becoming possible. The planet we're talking about? Proxima B. It orbits Proxima Centauri, the closest star to our own sun. It's just over 4 light-years away, a mere stone's throw in the grand scale of the universe. Sure, 4 light-years sounds like an eternity when we're talking about distances. But for the first time in human history, we have the technology, the vision, and the ambition to actually get there. It all started decades ago when astronomers first noticed something strange about Proxima Centauri, a tiny dim star in the constellation of Centaurus. They discovered that it had a planet orbiting in the so-called habitable zone. That means the planet could have liquid water and maybe even life. For many of us, that was a game changer. We had found a new frontier not just in the galaxy, but for humanity itself. For centuries, we've been dreaming of the stars. From the ancient Greek philosophers to today's tech billionaires and space agencies, the idea of exploring beyond Earth has driven human imagination and curiosity. But what if that dream could become reality? What if, by 2150, humans could actually set foot on Proxima B? Now, I know what you're thinking. 4 light-years? That's incredibly far. Our fastest spacecraft, like Voyager, is traveling at a fraction of the speed of light. It would take thousands of years to get there, right? So, what's changed? Why are we even talking about this? Well, over the past few decades, we've made incredible strides in space exploration. Think back to the first moon landing in 1969. Back then, people thought it was impossible for humans to even leave Earth's orbit. And yet we did. We've sent rovers to Mars, sent probes past the outer planets, and even sent messages to other star systems. We're starting to push the boundaries of what's possible. And here's the thing, in 2150, it won't just be a pipe dream anymore. Thanks to advancements in technology, humanity is on the verge of its first interstellar mission. The question isn't, can we do it? It's when will we do it? In this video, we're going to explore how humanity will make its first steps toward Proxima B. We'll look at the science, the technology, and the people behind this incredible journey. And we'll take a deep dive into the challenges and triumphs of what will be the biggest leap humanity has ever taken. So sit back and imagine yourself aboard the first interstellar ship, cruising through the vastness of space. And as we go on this journey together, we'll see how this dream became a plan, and how humanity will one day walk on another world. The first thing we need to talk about is propulsion technology. Right now, our fastest spacecraft are moving at speeds that seem fast to us. Voyager 1, for example, is traveling at about 38,000 miles per hour. That's impressive, right? But here's the catch. Voyager 1 traveling at that speed will take over 70,000 years to reach Proxima B. So, that's not going to cut it. But, thanks to some brilliant minds, we've been developing new propulsion methods that could cut that travel time down dramatically. First up, nuclear fusion. You've probably heard of fusion before. It's what powers the sun. If we can harness that energy in a spacecraft, it would give us an incredibly efficient way to travel at a significant fraction of the speed of light. Fusion-powered ships could potentially reach Proxima B in just a couple of decades. Imagine the possibilities. The problem, though? We still haven't quite figured out how to make fusion work in a controlled way for propulsion. But scientists are getting closer, and there's a lot of optimism about fusion reactors, especially with the breakthroughs we're seeing with projects like ITER, the world's largest fusion experiment. Next, we've got something called antimatter propulsion. Now I know what you're thinking, antimatter sounds like something straight out of Star Trek, and in a way it is, but believe it or not, we're making progress here too. When antimatter and matter collide, they annihilate each other, releasing an enormous amount of energy. Harnessing this energy could give us the ability to travel at near-light speeds. Sure, there's a lot of work to do, like figuring out how to produce enough antimatter and how to store it safely, but we're on the right track. And then, there's the Breakthrough Starshot project. This is one of the most exciting things happening right now. In 2016, a group of scientists and tech innovators, including people like Stephen Hawking and Mark Zuckerberg, announced an ambitious plan: send tiny, light-powered spacecraft to Proxima B. The idea is to launch these small, lightweight starships at 1/5 the speed of light using powerful lasers. These ships would take just 20 years to reach Proxima B, and they'd be able to send back data to Earth. Now, while this project focuses on sending small probes, not humans, it's a huge step in showing us that getting to another star is possible within our lifetimes. Now let's take a step back and look at the bigger picture. These propulsion breakthroughs are only one part of the equation. To make a real interstellar mission possible, we need to have advancements in life support systems, space habitats, and even AI to help manage the journey. Spacecraft traveling to Proxima B are going to have to be self-sustaining. After all, we're talking about a journey that could last decades, maybe even longer. We'll need closed-loop ecosystems to provide food, water, and oxygen. Imagine a ship that can grow crops, recycle waste, and create breathable air, all while traveling through the void of space. Technologies like hydroponics, algae-based oxygen production, and advanced water recycling systems will be key to keeping the crew alive for long stretches of time. And that brings us to artificial intelligence. As the journey to Proxima B could take decades, if not longer, humans won't be able to physically manage every aspect of the mission. That's where AI comes in. In fact, AI could play a huge role in managing the spacecraft, maintaining systems, and even helping out with day-to-day tasks. Think about it. AI could monitor the ship's life support systems, troubleshoot problems, and help the crew maintain their mental health by providing entertainment or assisting with communication back to Earth. Then there's robotics. While humans will be the ones making the long journey, robots will help with the heavy lifting. Drones, robotic arms, and automated systems could handle everything from ship repairs to collecting data from distant stars along the way. This is an important part of the plan, because let's face it, in space, things break down. A lot. And let's not forget communication. This is a tricky one because space is really big. Even though Proxima B is close in terms of cosmic distances, it's still 4.24 light-years away. That means any communication from the crew would take over 4 years to reach Earth. 4 years for a single message. So, how do we manage that? Well, we'll need to rely on AI to help bridge the gap, working as the intermediary between the crew and Earth, relaying information and making critical decisions, even when there's a significant delay. So while the idea of sending a spacecraft to Proxima B might sound like science fiction, the truth is, we're already taking the first steps to make it possible. And as these technologies continue to develop, the dream of interstellar travel is becoming more and more tangible. Alright, so now we know the science and technology behind this ambitious mission to Proxima B. We've got propulsion systems that could get us there in just a few decades. We've got AI and robotics ready to help us manage the journey, and we've got the life support systems to keep astronauts alive for the long haul. But here's the big question. Who's going to make all of this happen? Who's going to foot the bill for something that sounds like the plot of a sci-fi movie? The answer? A mix of visionaries, governments, and private investors. Because let's be honest, this is no small feat. The money, the resources, the expertise, it's all got to come together in a way that turns this dream into a reality. And that's exactly what's been happening behind the scenes. It all starts with the visionaries, the people who dream big. We're talking about the people who have been looking up at the stars and thinking, what if? From the likes of Elon Musk and Jeff Bezos, who are already investing in the future of space travel, to scientists and astronauts who've dedicated their lives to exploring the unknown. These are the folks who are setting the stage for something as ambitious as a mission to Proxima B. Take Elon Musk, for example. Through SpaceX, he's already made a name for himself by pushing the boundaries of space travel. His company has reduced the cost of launching rockets, made reusability a reality, and even started planning for human missions to Mars. Musk's vision for humanity is clear: we need to become a multiplanetary species, And as ambitious as it sounds, he's already taken huge steps toward that goal. So when you think about a mission to Proxima B, it's not that far-fetched to imagine SpaceX being part of the team that could make it happen. Then, there's Jeff Bezos and his company Blue Origin. Bezos has talked about humanity's future in space for years, and his vision revolves around something a bit different, establishing large space habitats and making space tourism a reality. He's focused on making space accessible to everyone, and that mindset could play a huge role in making interstellar travel something that's within reach. Sure, Blue Origin is still working on building up its space infrastructure, but Bezos is in it for the long haul. He's made it clear that he believes in the future of humanity in space, and that future might just include a trip to Proxima B. But it's not just billionaires who are working on this. Governments and international space agencies like NASA, the European Space Agency, and China's space program are critical players as well. For something of this scale, cooperation between countries is going to be essential. Think about it. No single country can afford a project like this alone. The cost of building the spacecraft, the technology, the infrastructure, it's astronomical. So these agencies are already pooling their resources, sharing knowledge, and working together to make deep space travel possible. Private companies start making these kinds of advancements, it opens the door for new investors to step in. The key here is public-private partnerships. Governments provide the funding and resources to lay the groundwork, while private companies take the lead on the innovative tech and the heavy lifting. It's a mix of expertise and capital that could make all of this possible. But it's not just about throwing money at the problem. There's a serious logistical challenge too. Think about it. This isn't just a mission to send a probe to Mars. This is a mission that will span decades, possibly longer. A journey to Proxima B will require an entire ecosystem of support, from mission planning to spacecraft construction, from training astronauts to developing the AI systems that will guide them. This is going to require a level of international collaboration, innovation, and long-term commitment that we've never seen before, and here's where things get interesting. These are not just tech billionaires and government agencies working on this. Public interest in space exploration has been growing, especially with the rise of space tourism and the increasing visibility of private companies in space. People are excited about the possibility of humans exploring other worlds, and that excitement is driving investment and innovation at a pace we've never seen before. So, what does this mean for our mission to Proxima B? It means we're not just waiting for a future where interstellar travel is possible, we're actively building it right now. And as these visionaries, investors, and international agencies continue to push the envelope, humanity is getting closer to making the unimaginable possible. Okay, so now we know the dream is real, the technology is catching up, and the funding is coming in. But like any journey worth taking, the road to Proxima B is not going to be without its fair share of challenges. And we're not talking about just a couple of obstacles here and there. This is an interstellar mission we're talking about. The kind of challenges we face are going to test humanity in ways we've never experienced before. Let's start with the big one, the sheer distance. Proxima B is over 4 light-years away, and that's just the beginning. Even if we're able to send a spacecraft with the best propulsion technology we have, we're still dealing with the vast emptiness of space. Space is big. Like really big. And no matter how advanced our tech gets, we still have to deal with the fact that the farther we go, the more difficult it is to communicate, to maintain life support, and to ensure the crew's safety. This brings us to the communication problem. Imagine you're an astronaut aboard a spacecraft, traveling at near light speeds, heading toward Proxima B. You're months, even years away from Earth. And if something goes wrong, if there's an emergency or a malfunction, how do you get help? The simple answer is, you don't. Not right away anyway. Even with the best technology, signals traveling back and forth from Earth would take years to reach you. Take this into perspective. If something happens, and you're 10 years into your journey, it would take 10 years for a message to get back to Earth, and then another 10 years for the response to get back to you. That's 20 years to solve one problem. It's kind of mind-boggling when you think about it. So the astronauts will have to rely on self-sufficiency and problem-solving. And it's not just about communication with Earth. Think about navigation. Space is vast, and when you're traveling toward a distant star, the slightest mistake in direction could have you missing your target by millions of miles. You can't just stop and ask for directions out there. Advanced AI and autonomous systems will play a huge role here. These systems will need to take over the task of navigating, making course corrections, and ensuring that the spacecraft stays on track for decades with minimal human interference. Now let's talk about radiation. Space is filled with high-energy particles, cosmic rays, and solar radiation that can be harmful to both astronauts and spacecraft. For the crew of a mission to Proxima B, this is a huge concern. The further we travel from Earth, the more exposure we have to these dangers. Our atmosphere and magnetic field here on Earth protect us from much of this radiation. But once you're in space, you don't have that safety net. To make things even trickier, radiation exposure builds up over time. So, a mission lasting decades means a prolonged period of vulnerability. And it's not just about the spacecraft being damaged, it's about the health risks for the astronauts. Increased radiation exposure can lead to everything from cancer to cognitive decline. So how do we protect the crew from this? There are some solutions we're exploring right now, like radiation shielding. We're talking about thick layers of material, whether it's water, magnetic fields, or even regolith from the Moon or Mars, that can protect the spacecraft and its crew. But of course, the challenge is balancing the weight of that shielding with the overall efficiency of the spacecraft. After all, the more weight you carry, the more fuel you need. And the more fuel you need, the more you add to the cost and complexity of the mission. And let's not forget about human health in general. Long-term space travel means dealing with the effects of microgravity on the human body. In low-gravity environments like the ones found on the International Space Station, astronauts experience muscle atrophy, bone density loss, and other health issues. That's a big deal for a mission that could last decades. To counteract these effects, we'll need to develop advanced exercise regimens, medications, and possibly even artificial gravity on board the spacecraft. Imagine being on a ship for 20 years with your body slowly weakening. We're going to have to find a way to keep the astronauts strong and healthy for the long haul. Now, on top of all these physical challenges, we also have to think about the psychological toll. It's one thing to send astronauts on a mission to the Moon for a few weeks. It's another thing entirely to send them on a journey to a distant star system, where they'll be isolated for years, possibly decades, without seeing another human face. They'll be stuck on a ship in deep space with no one but their crew to rely on for companionship. The mental and emotional challenges of long-term space travel are just as important as the physical ones. And it's not just about isolation. There's also the issue of boredom. Long stretches of empty space where nothing changes and nothing happens. The crew might feel like they're just drifting through the void, and that can take a toll on their mental health. Astronauts today go through intense psychological training to prepare for short missions, but we're talking about a whole new level of isolation. We'll need to provide them with meaningful work, ways to stay entertained, and constant support to keep their morale high. So, how do we overcome these roadblocks? Well, we've got a lot of work ahead of us, but we've overcome seemingly impossible odds before. Think back to the Apollo missions, when we sent humans to the Moon with technology that, compared to today, was practically ancient. And here we are talking about interstellar travel. Each challenge, whether it's radiation, isolation, or the basic logistics of getting a spacecraft to another star, is an opportunity for innovation. We'll need to push the boundaries of everything we know about science, technology, and human endurance. It's a monumental task, but it's one that humanity has the ability to tackle. It's just going to take time, creativity, and a lot of hard work. And of course, a bit of courage. Now let's dive into something that will absolutely be a game changer for our mission to Proxima B, artificial intelligence and robotics. These two technologies are going to be absolutely essential for the success of the mission. Why? Well, think about it. When you're sending humans on a journey to another star, you're not just dealing with space travel. You're dealing with an incredibly complex system that's going to have to operate for decades, maybe even longer, without constant human supervision. And that's where AI and robotics come in. First up, let's talk about AI. Artificial intelligence has already started to play a huge role in space missions today. For example, NASA's Curiosity rover on Mars uses AI to make decisions about where to go, what data to collect, and how to adjust its behavior based on the environment. But here's the thing. When you're traveling to Proxima B, the level of complexity is on a whole other level. The spacecraft won't have a direct line to Earth for guidance. It can't just call home and ask for help if something goes wrong, so AI is going to have to take on an even bigger role. One of the biggest tasks for AI will be autonomous system management. Think of it like this. AI will be the brain of the spacecraft, making sure that everything is functioning as it should. From monitoring life support systems to managing power, AI will be responsible for keeping the ship running smoothly. And it's not just about fixing problems that might come up, it's about predicting potential issues before they happen. AI will need to monitor every aspect of the spacecraft, learn from the data it collects, and make adjustments on the fly to prevent failures. But AI won't just be fixing things behind the scenes. It will also be working with the crew. In fact, AI could act like a virtual assistant for the astronauts. Imagine having an AI on board that helps with everything from scheduling to health monitoring. The AI would track the crew's physical and mental health, offering suggestions for exercise, sleep patterns, and even diet. On a journey that lasts decades, staying healthy, both physically and mentally, is critical, and AI could play a huge role in keeping the crew in. Now let's shift gears a bit and talk about robotics. Robots will be the true workhorses of the mission. They'll handle tasks that are too dangerous, too complex, or simply too mundane for human hands. And let's be honest, in space, things go wrong. Equipment breaks down, systems fail, and parts need to be repaired. But sending humans out to fix things in deep space could be risky. That's where robots come in. They'll perform routine maintenance, inspect the spacecraft for potential damage, and make repairs when necessary. We're already seeing robots doing some of this work today. For example, on the International Space Station, robots like the Canadarm2 help astronauts with spacewalks and moving equipment. But in the context of a mission to Proxima B, robotics will need to be much more advanced. Think of drones that can fly around the spacecraft, checking for any signs of wear and tear. Think of robotic arms that can repair damaged systems without requiring human intervention. These robots will be constantly on the lookout, ensuring that everything continues to function as smoothly as possible. But here's the tricky part. The farther we travel from Earth, the harder it becomes to send commands to these robots in real time. You see, the farther the spacecraft gets from Earth, the more delayed the communication becomes. So in addition to AI being responsible for managing the ship's systems, these robots will need to be autonomous too. That means they won't just be following simple commands. They'll be making their own decisions based on the environment around them. For example, let's say one of the spacecraft's engines starts to malfunction. A robot could detect the issue, perform a diagnostic, and even try to fix it, all without waiting for approval or instructions from Earth. It's this level of autonomy that's going to make space exploration possible in the farthest reaches of the galaxy. These robots could also assist with scientific exploration. Imagine sending a robot to the surface of an exoplanet, equipped with tools to collect samples, analyze the atmosphere, and send data back to Earth. Robots will be the ones going out into the unknown, collecting data and sending back valuable information about the stars, planets, and moons we're exploring. They'll be our eyes and ears out there in the deep, dark expanse of space. On top of that, robots could help construct infrastructure for future missions. Imagine building space stations or even habitats on Proxima B using a fleet of autonomous robots. They could mine resources from the planet's surface, build shelter, and prepare the area for human arrival, all without us even being there yet. But for all the talk about AI and robots, let's not forget that humans will still be at the center of this mission. AI and robotics are tools designed to support and assist the astronauts, not replace them. The ultimate success of this mission will depend on human ingenuity, determination, and the ability to adapt to the challenges of living in deep space. AI and robotics will be our partners, working alongside us to make sure that we can achieve the unimaginable, reaching Proxima B and ensuring that humanity's first steps on an exoplanet are just the beginning. Alright, now that we've covered the challenges and the tech that will support this mission, let's zoom in on the heart of the whole operation, the spacecraft. Think about it for a second. This isn't just any ordinary ship we're talking about. This is the vessel that will carry humanity to another star system. It needs to be designed to handle everything, from the physical strain of deep space travel to the psychological and physiological demands of keeping a crew alive for decades. Let's start with the most fundamental aspect of the spacecraft, propulsion. You've already heard about the next-generation propulsion technologies, but building a ship capable of using them is a whole different ballgame. In a conventional spacecraft, we rely on chemical propulsion, but this doesn't even come close to being fast enough for interstellar travel. Even the fastest chemical rockets we have would take thousands of years to reach Proxima B, so we need something way more advanced. One of the top candidates for this mission is nuclear fusion. This could be the key to making interstellar travel feasible within a human lifetime. Fusion propulsion would essentially use the same principle that powers the sun, fusing hydrogen atoms to create massive amounts of energy. The real game changer is that fusion produces way more energy than chemical reactions. That means we could potentially travel at a significant fraction of the speed of light, getting us to Proxima B in a matter of decades instead of centuries. But here's the catch. Nuclear fusion technology is still in its infancy. We're talking about a spacecraft that relies on a power source that we haven't fully perfected yet. So, engineers will have to design the spacecraft to handle this new form of energy, ensuring that it can generate and contain the immense power needed to propel the ship across light years. Now, let's think about the structure of the spacecraft itself. It's got to be able to withstand the harsh conditions of space, high levels of radiation, extreme temperatures, and even the occasional micrometeorite impact. But at the same time, it can't be so heavy that it makes the whole mission impossible. So, the materials used for the spacecraft will need to be lightweight, but incredibly durable. We're talking about materials that have to be both strong enough to endure the elements of space and light enough to allow us. One approach could be carbon nanotubes. These super strong, lightweight materials could help form the spacecraft's hull, making it resistant to space debris and radiation while keeping weight down. Think of it like building a ship that's as light as a feather but tough enough to handle the harshest conditions out there. And it doesn't stop there. The spacecraft will also need to be equipped with radiation shielding, not just to protect the crew, but also the delicate electronics and systems that will be essential for keeping everything running smoothly. But the structure isn't just about protecting the ship. It's about sustainability for the long journey. This spacecraft isn't just a shuttle that gets us from Earth to the Moon in a few days. This is a self-sustaining, closed-loop system that needs to function on its own for decades. So we'll need to design life support systems that can recycle air, water, and food for the crew, systems that can work without any input from Earth. This means developing advanced bioregenerative systems. These are systems that use plants, algae, or other organic materials to regenerate resources like oxygen and food. The idea is that the spacecraft would be able to grow food on board, recycle water, and use the crew's waste to help feed plants. Essentially, the ship will become a small, self-sustaining ecosystem where everything is reused and recycled and nothing goes to waste. But maintaining a closed-loop system isn't just about technology, it's about maintaining a balance. Think about it. Imagine you're a crew member and you've been living in a small spacecraft for decades. Every time you breathe, every time you drink, every time you eat, it's all part of this delicate system. If something goes wrong, say the oxygen levels start to dip or the food supply gets contaminated, everything could come crashing down. So the systems in place need to be constantly monitored by both AI and the crew, ensuring that nothing goes awry. Now let's talk about crew quarters. This spacecraft will be home for astronauts for a long time, decades, possibly more. So it's not just about the technology, it's about creating a livable environment. These crew quarters will need to be comfortable, practical, and mentally stimulating. There's only so much time you can spend in a confined, windowless metal box without losing your mind. That means creating spaces that allow for privacy, relaxation, and entertainment. Spaces that feel like home, even if it's a home floating in deep space. What's interesting is that the spacecraft will also need to accommodate artificial gravity. Since astronauts will spend years in microgravity, their muscles and bones will begin to weaken over time. Artificial gravity would help mitigate these effects, either through rotational force, creating a spin that simulates gravity, or through other technologies that keep the crew physically healthy. And here's a question we need to think about. How do you keep the crew motivated? How do you keep them focused on the mission and their well-being when they're in space for so long? The spacecraft will need to include areas dedicated to physical and mental health. Exercise rooms, recreation areas, even virtual reality environments for mental stimulation could help keep spirits high. It's a big deal, because the psychological aspect of long-term space travel is just as important as the physical. On top of that, there will be advanced medical systems on board. We're not talking about just basic first aid kits here. This ship will need fully equipped surgical suites, telemedicine capabilities, and AI-driven diagnostics to monitor crew health. In case of emergencies, the ship's medical systems will have to be able to handle anything, from injuries to diseases, without waiting for help from Earth. The spacecraft design is basically an engineering puzzle, a massive one. Every piece of technology, every system, every material choice must be optimized for space. Because remember, this isn't just about going to another planet within our solar system. We're talking about interstellar travel. Every part of this spacecraft will have to be tested and perfected. And we're only just beginning to scratch the surface of what's needed to build this kind of ship. Now, we've talked a lot about the spacecraft, the tech, and the challenges of getting to Proxima B. But there's one part of this entire mission that we can't forget. The crew. We can have all the technology in the world, but at the end of the day, it's the astronauts who are going to make or break this mission. These men and women will be the first to take humanity's steps beyond our solar system. They'll have to be ready for the unknown, and that means they'll need training like no other astronauts before them. So, let's think about what training for this kind of mission will look like. First, these astronauts will need to be physically fit. But it's not just about being strong or fast, they'll need to train to handle the physical demands of deep space. For one, we already know that prolonged exposure to microgravity causes serious health problems. Muscle atrophy, bone density loss, and fluid shifts in the body. Astronauts will need to spend hours each day on exercise regimens designed to keep their muscles and bones strong. On top of that, they'll need to be in top cardiovascular shape to withstand the long journey and the potential stress of an emergency. Then there's the mental fitness. Long-term space missions take a toll on the mind too. Being cooped up inside a spacecraft with the same crew for decades, no fresh air, no change of scenery, no quick getaway to Earth for a weekend vacation. It's a mental marathon, and astronauts will need to be prepared for it. Psychological training will be just as important. One major part of this will be team dynamics. These astronauts will need to live and work together in very close quarters for years. And while that sounds like a dream for some people, being in a confined space with a small group of people for decades will test even the best of relationships. There's nowhere to hide when you're on a spacecraft heading toward another star, so conflict resolution, communication skills, and emotional intelligence will be critical. They'll need to build strong bonds as a crew because the psychological toll of isolation and tension could be just as dangerous as any physical problem they face. Astronauts will also need to be problem solvers, capable of thinking on their feet when something goes wrong. With a spacecraft that's literally traveling to another star, unexpected challenges are going to pop up, and they're not always going to be fixable with a quick phone call to Earth. These astronauts are going to have to be able to troubleshoot, fix broken equipment, and make critical decisions with no outside help. They'll need to be highly trained in everything from engineering to medicine to basic survival skills, and this goes beyond just technical training. We're talking about decision-making under pressure. Think about it. If something goes wrong, say, a critical piece of equipment fails, or there's a system failure that threatens the life support systems, they're going to have to make life or death decisions in a split second. The kind of training they'll go through will simulate these high-stakes situations, preparing them for the worst-case scenarios, so they can keep their cool when things go south. Another key aspect of training will be the scientific knowledge required for this kind of mission. These astronauts won't just be travelers, they'll be pioneers, scientists, and explorers. They'll need to understand everything from astronomy to geology and biology, because when they get to Proxima B, they'll be conducting experiments, collecting data, and learning more about this distant world than we ever have before. They'll also need to be able to analyze data and adapt quickly to new environments, especially if they encounter alien life forms or unknown biological materials on the planet. The training won't stop once they've launched either. As the mission progresses, the crew will have to stay on top of new technology, constantly updating their skills and knowledge. Even with AI and robotics doing much of the heavy lifting, the astronauts will still need to be the human element that makes the final call. And that means ongoing education and adaptability, even once they're already on their way to Proxima B. But what about the emotional toll of such a long mission? Can you imagine the impact of knowing you won't see your family, friends, or home for decades? How do you prepare for something like that? Well, one solution might be virtual reality. VR could help astronauts stay connected to Earth by providing them with experiences that simulate real-world environments, like the sights and sounds of their hometown or a walk through a forest. It could be a way to combat the feeling of isolation and offer a mental escape when things start to feel too overwhelming. And let's not forget about communication with Earth. Even though there will be major delays in communication, astronauts will still be able to send messages back and forth with family and friends. But think about the emotional side of that. How do you explain to your kids that you won't be home for 20 years? How do you maintain relationships when time itself becomes a barrier? It's going to be tough, and that's why astronauts will need to be mentally prepared for the long-term emotional strain of being so far from home. So, in addition to physical and technical training, there will be a significant focus on mental resilience. These astronauts will need the skills to stay motivated and focused on the mission even when things get tough. And that means not just preparing them for the journey, but preparing them to stay connected to their purpose. The future of humanity. The legacy of their mission will not just be about getting to Proxima B, it will be about ensuring the survival and expansion of the human race. The mental strength to carry that responsibility will be key. Now, one final aspect of training that's crucial is leadership. In such an isolated environment, the crew will rely heavily on their leader to keep morale high, make tough decisions, and guide them through challenges. Leadership training will be tailored to help these astronauts manage stress, foster teamwork, and inspire confidence because the crew will be looking to their commander in the most critical moments. Finally, after decades of preparation, the moment we've all been waiting for arrives. The spacecraft lands on the surface of Proxima B. This is humanity's first steps on an alien world, and it marks a new chapter in our history. But before we get too ahead of ourselves, let's think about what this first contact with another planet will actually be like. We already know Proxima B is in the habitable zone of its star Proxima Centauri, meaning it could have conditions suitable for liquid water. But what exactly will the planet look like? The surface of Proxima B is still largely a mystery. Will it be covered with vast oceans, barren deserts, or dense forests? How different will it be from Earth? And most importantly, what will the air be like? The very first thing astronauts will have to do is analyze the atmosphere to determine whether it's breathable, whether it has enough oxygen, or whether they'll need to wear protective suits for an When the astronauts step out of the spacecraft, they'll need to be cautious. We don't know what the surface conditions will be like. The planet could have extreme weather patterns, violent winds, intense radiation from its star, or even unpredictable magnetic storms. The astronauts will have to set up shielding around their landing zone, probably using materials from the spacecraft itself to protect them from any immediate dangers. But once they're out there, walking on Proxima B's surface, they'll be pioneers. Humans walking on a world no one has ever touched before. The first task will be setting up a base of operations. This base won't just be a place to rest, it will be their hub for everything: living, studying, exploring, and surviving. The crew will need to establish solar power systems to generate energy, create an atmosphere for breathable air, and begin to grow food. They'll also have to create a system for collecting and purifying water, which will be crucial for long-term survival. This isn't just about setting up a few tents and calling it a day. They're laying the foundation for humanity's first colony on an alien world. Next, they'll start collecting samples from the surface, rocks, soil, and even the air. They'll use advanced tools to analyze the environment and determine whether there are any signs of life. This could take years. Proxima B is so far from Earth, and getting precise data back will be a slow process with the vast communication delay. But the crew will need to be patient. They'll use advanced robotics and AI-powered tools to help them map the area, search for water, and test for any forms of life, whether microbial or otherwise. But here's the thing. While Proxima B might be Earth-like, it might also be unrecognizable in some ways. Even if it has liquid water, it could have strange chemical compounds, alien life forms, or unexpected weather patterns. There could be geological processes at work that we don't fully understand. For example, the planet might have high levels of volcanic activity, making it unstable in certain areas. It might have a magnetic field that behaves completely differently from Earth's, which could affect navigation and communication. In these early days on Proxima B, the astronauts will be working hand in hand with AI and robotics to navigate and survive. These technologies will help them analyze soil samples, construct habitats, and even perform tasks like drilling for water or mining for resources. But they'll also be constantly testing and adapting. Every experiment, every task, will have to be carefully planned and executed because there's no quick way back home. If something goes wrong, they're on their own. And of course, we can't forget the psychological challenges the astronauts will face. They've already been in space for decades, but now they're on an alien planet, isolated from Earth. The pressure to succeed will be overwhelming. They will carry the weight of all of humanity's hopes and dreams, knowing that every move they make will affect the future of our species. The isolation, the uncertainty, the danger, it could all start to take a toll. That's why building a strong, supportive crew dynamic will be essential. It will be more important than ever for them to stay mentally and emotionally strong, to keep their focus on the mission even when things get tough. One of the most exciting aspects of the mission will be scientific discovery. This is humanity's chance to explore an entirely new world, and the scientific community will be hanging on every bit of data that comes back. The astronauts will collect samples from the surface, minerals, atmospheric readings, and perhaps even traces of life, and send them back to Earth. Over the course of years, these samples will be analyzed, offering us insights into the planet's formation, its potential for supporting life, and how it compares to Earth. They could also discover something completely unexpected, maybe a form of life we've never encountered before, or a surprising geological feature that could unlock new secrets about how planets form and evolve. The long-term survival of the crew will depend on their ability to adapt to Proxima B's environment. As we said, the planet could be radically different from Earth in many ways. The crew will need to grow food, find water, and build structures that protect them from the elements. They'll need to learn how to use the planet's resources to sustain themselves, whether that's through local farming or by using advanced terraforming techniques to modify the environment for human habitation. In the early years, contact with Earth will be limited. Communication will be a huge challenge. Messages will take years to get through, and the astronauts will need to be prepared for long periods of uncertainty. They won't be able to rely on Earth for daily support. They'll have to solve their problems on their own, and that's going to be one of the most difficult and rewarding parts of the mission. The first settlers on Proxima B will be truly isolated, living in a world where they are humanity's only representatives. But what happens after they establish their base? Will other missions follow? Will Proxima B eventually become a hub for further exploration of the Alpha Centauri system? Will we begin to terraform Proxima B, turning it into a second home for humanity? This is just the beginning of a new era. The first steps on Proxima B could lead to the first interstellar cities, the first colonies beyond our solar system. This mission will lay the groundwork for a new frontier, a place where humans will begin